The video heading is Curious Case of Water. So let me go on to the screen. See guys, this is something that we see. Typically, what do we see if we have a liquid, right? If you heat it, if the temperature rises, what we get to see is that it expands. Okay. Water also does this, but it has an exception. And that's what we are looking at. Water too is a fluid. It also expands. But there is an exception. This very exception has made life possible on the surface of the earth. If not for this, things would have not been this, at least not this. Maybe life would have been there, maybe some other form, but not this at least, not this way at least. So let's see what is that we are going to talk about. See, first thing is as usual, I have a flask with water. This is not any liquid, this is water. But this is at a temperature of 0 degrees Celsius, a value which is less than, not 0, sorry, minus 1 degree Celsius, a value less than 0 degrees Celsius. Say this is at 3 degree Celsius and say this is at 8 degrees Celsius. So this is a value which is less than 0 degrees Celsius. This is between 0 degree to 4 degrees Celsius, and this is a value greater than 4 degrees Celsius. Now, what we are looking at is you have the volume to be V0. Okay, again, I'm taking a container with basically iced water, and the volume I'm calling it as V0. So here I start to heat it up. I'm heating. So what we'll see is there's a weird behavior. Typically, what should happen? The volume should increase, right? Typically, this should be the behavior. But what we'll see is there will be a drop in the volume. And after 4 degrees Celsius, what we'll see is things will start to increase again. So this implies there is the volume drop, and this implies volume starts to increase again. So this is the weird behavior of water. So first, let me show it this way. First, there is certain value. The volume reduces and then again it starts increasing. Typically, the volume, as in when you heat any normal liquid, right? Most of the liquids, it will just follow this manner, a linear increase in volume. We have seen those formulas. But when it comes to water, it drops and then again it increases. Okay, this is your volume temperature graph. The blue line represents water and the orange line represents your normal liquid. Now, there's one more thing that we need to discuss. So this is basically the curious aspect about water. That's it. So next thing that we need to discuss is the following. If the density over here is rho naught, what is the density over here? Is it rho naught minus rho 1 or is it plus? Is it minus or plus? That's the question. So the density will increasing. Volume drops, mass is not changing. And so what happens? The density has to increase. Okay, volume is reducing, so the denominator is reducing. And so the density has to increase. So here, this case is an example of density. So this is an important observation. So this explains why we have life as it is. If not for this behavior, life would not be, at least not in this manner. Okay, moving on. So what is the density over here? So obviously it is reducing. Okay guys, so this is your bunch of things that we need to keep in mind. Okay, so let's look at the graph. So typically the density keeps on reducing for your normal liquid. while the density of water, it peaks at 4 degrees Celsius and then it drops. So this graph is the anomaly, it's the variation, it's the difference. So that's your curious case of water. So let's read through and we'll also understand why this happens. Okay, so let's read through this first though. The curious case of water, usual behavior of liquid. Most liquid expands when heated and contracts when cooled. Good. The volume expansion is typically about 10 times larger than that of the solid. Okay. Water strange behavior. Okay. So what is the strange behavior of water? Between 0 degrees Celsius to 4 degrees Celsius, water contracts. Right? It shrinks. Unlike other liquid, water shrinks as it heated from 0 degrees Celsius to 4 degrees Celsius, and thus density increases. While at 4 degrees Celsius, very important, the water has the maximum density, that is the least volume. And post 4 degrees Celsius, water begins to expand normally and the density drops again. But why is this happening? It's because of this. When you have water, right, liquid water, when you cool it, it starts to form this structure. If you can, we'll also put that, but if you can, please web search, what is this? Snowflake structure. You see this beautiful structure, every time you see different structure. There's a lot of science to it. So we have a lot of understanding now. Science is also, the Western science is also finding the same thing. But anyways, point is, you see this beautiful structure. So this happens when you have solid ice. Let me read through. Let me explain what is that we are looking at. Why does this happen? Hydrogen bond, open structure. That's the answer. So near 0 degrees Celsius, water molecule arrange themselves in an open cage-like structure due to hydrogen bonding. Something like this. Okay. This structure occupies more space. So more space means larger volume, means lower density. Okay. Now, when we start heating it from 0 degrees Celsius to 4 degrees Celsius, you can imagine that this bonds between hydrogen atoms. Added heat breaks this open structure. The molecules can move closer and pack more tightly. So before it was well structured like this at 0 degrees Celsius or below. So all of this, you can see the dotted line, it starts breaking. Okay. It starts breaking, and because it breaks, there's more space for the molecules to occupy and they start coming together. So the water contracts and density increases, reaching a maximum of 4 degrees Celsius at 4 degrees Celsius. Post 4 degrees Celsius, now the normal thermal expansion dominates, molecules moves faster. There it was Sida Sada sitting around and cozying together. Post 4 degrees Celsius, what happens? It starts to expand again. Therefore, volume increases, density decreases. So this is the stuff. So basically here, if I zoom in, I think, okay, I can make it over here. No, everywhere there's some space over here. So this guys, basically, so you get to see some structure like this. Okay, not a good diagram, but if I zoom in, this can be it. Here, they're broken, they're close by, they're closely packed. So that's supposed to be a magnifying glass. That's what I'm trying to indicate over there. And post that, what happens? They start to vibrate more, and as the usual story that we have seen before, they need more space and so they will start expanding. Okay. So that is because of hydrogen bonds and stuff. So finally, the key thing that I kept telling, importance in nature. As lake cools 4 degrees Celsius, water sinks. Right? Because it's the densest of water at any given temperature. Water below 4 degrees Celsius stays above. So basically, if a lake starts to freeze, right? Instead of, I have a small story. So basically, if you have a lake per se, I think you guys have seen this when you guys were kids. So lake freezes, right? And you've seen this in movies also. So lake freezes and there is water below, and it is 4 degrees Celsius over here, basically. Whatever the temperature is above, it doesn't matter. This is 4 degrees Celsius. So here it can be some minus X degrees Celsius, it doesn't matter. And because of this, the living things can cozy up over here and they can stay over here. Okay, so that's the whole funda. Because it's the densest. Density is highest. So since the density is highest, it will sink down. As simple as that. Very simple. Okay guys, you can have a look. I think I'll show this itself. Oh yeah. So by mistake, we had a glass bottle with kombucha. So it's a tea kind of thing. Good for your gut. By mistake, someone kept it in the freezer and it was in liquid form and it froze, and so it broke the glass. So yeah, this is a possibility. If you have a very tight container, a liquid in a very tight container, if you keep it in freezer, this is a possibility. Okay, so it broke and yeah, basically we couldn't use it. So that's that. So you have to be careful when you're dealing with liquid and freezers. Okay, so you can copy this. And I think this graph is better. Then you can write the written part. And then this, I guess. And now the written part.